All right, let's go over our book quiz, and we are going to do a lab today. So then we'll talk about our lab. Lost my pen. Grumpy. All right, so these are like what the test is going to be like. So these are from our Unit 4 test bank. So this question says, what are elements most likely to be present in the star due to this emission spectra? So these are our reference spectra. This is what we're going to match to. This is our unknown, our star. So based on our reference spectra, what is in our star? Yeah.
Helium and hydrogen.
Good, helium and hydrogen. So we can find that by just matching up the lines. Okay, those different lines represent different wavelengths of our light. So helium and hydrogen. Good. Questions on that? You guys think you could do that on a test? Okay. All right. Next question. Atomic emission spectra are the result of what? Are they a result of, so when an electron moves in an atom, what causes that? Microwaves, visible light, gamma rays. Yeah, Matthew?
I believe the electronic transition is from emission.
Good, emission, good. And these are called emission spectra. That's what's giving those. An electron goes from a high energy to a low energy orbital, and that energy difference emits a photon. Okay, good. All right, next question. Blank is when an electron moves from a high energy state to a low energy state, and a photon is blank. So I just told you that right now. That's emission. When you go from a high energy state to a low energy state, that's called emission, and a photon is emitted. Okay, when electrons absorb visible light, changes occurring inside of an atom. Which of the following describes this change? So we just talked about emission. What would absorption be? Absorption is like the opposite.
Absorbing.
Good. Absorbing a specific amount of energy. Good. Very good. Okay, questions on this? Do you guys feel like those are fair test questions? Okay, no objections. All right. Okay. So make sure you got submitted. All right. Let me go ahead and find my slides. I think I forgot to pull them up. So we are going to do our Calorimetry Lab. I looked, and the weather, it is 63 degrees. Here we go. So I think
tomorrow at flex for the lab.
You'll just do the makeup lab.
Oh.
Yeah. Oops. So we're going to go outside. We're going to burn some food, and we're using the outside as ventilation. So our goal today is to figure out how many calories are in a piece of food. Okay. So let's just go back to, this is our calorimeter. Okay. Today we're going to use a different kind of calorimeter, but the basic properties of a calorimeter, you have some kind of liquid, we're going to use water, and then you have your sample, and you're going to burn your sample, and the heat from your sample goes into the water, and then you can measure the temperature change of your water. So that's what we're going to do today. Okay, so we're going to use this equation. This is the heat from our food. N is the mass of the water. So this side has to do with water. This side has to do with our food. Okay, so M is the mass of our water. C is a constant. That's called the specific heat. If you've taken physics, you should have talked about specific heat. And then delta T is the final temperature minus the initial temperature of our water. Okay, and I'm gonna grab some things from our lab so we can see what we're going to do today. Okay, So this is going to be our calorimeter for today. So just be aware. I've cut a hole in this pop can, and I've tried to fold most of the edges over, but especially the top is pretty sharp. So be really careful when you're handling this. This can cut you. Okay, so just be cautious when you're moving this. Okay. All right, so this is going to be the chamber that we burn some food in. Oops, wrong way. So just like we have our sample chamber, this is going to be our sample chamber. Okay, but there's lots of oxygen in the air to burn our sample, and then you also need a sample holder. So don't throw this away when you're done. We're going to use this probably next year. So this gives us a place to put. You're going to put your piece of food on the top. That makes it so air can move around your piece of food and burn it pretty easily. So last year we put our piece of food on the bottom of the can, and they didn't burn very well, mostly because it was windy, but also because the air couldn't get all the way underneath the food. So for a fire, you need oxygen. If we were doing this in a fancy calorimeter, we would charge this. It's called charge it with oxygen. We would pump oxygen into our chamber so that it has enough oxygen to burn. But we're just need there. Okay, so that's our sample holder. Whatever food you burn, you're going to put it on here. Then you're going to take your piece of food and put it in our little furnace really carefully so you don't cut yourself. Let me know if you cut yourself. We can get you a Band-Aid. And then this is going to be our water container. So this one doesn't have a hole. So you're going to fill this about a third with water. The amount doesn't matter too much. If you fill it too full, then the scales we're using aren't sensitive enough. It'll say like error. If you get that error, just dump some of the water out. Okay. So about a third shouldn't make the scale angry. You need to know the mass of the water. So how can I measure the mass of the water if I'm using this can? Yeah.
I'll put the can on the scale first and then zero out the scale and then fill with water.
Okay, perfect. So you can zero out the scale with the can and then add water. Perfect. Another way to do that, basically the same thing would be to measure the can first, figure out the mass of the can, and then measure the can and the water, and then subtract off the can. So you could either do it the Isaac's way, or you could do it measuring the can first. So either way, but you need to record somewhere in your notebook, you need to record the mass of the water, okay? Or your calculation won't work. So you have to have the mass of the water, otherwise you won't figure out what we're talking about. So we're going to do 2 food items twice, and that seemed like then we had enough time to come back in and finish our lab. If you want to measure 3 food items, we'll probably have time, but I think 2 pieces of food was plenty, and then we can finish our lab. So when you report on your lab paper, you should report 4 different calories. So if I measure Cheetos, I should have 2 answers for Cheetos, and maybe I measure almonds, 2 answers for almonds. Okay. So we're trying to build in some averages a little bit. Okay. All right. So this, go ahead and write this on a notebook or a piece of paper so that this is some of the data that we need. You need to record the mass of the water. So there's 2, maybe more ways of figuring that out. But you need to know the mass of the water. And then we also need this constant C. This constant C is called our specific heat of water. And for water, this constant is 1 calorie per gram Celsius. So when we measure our temperature of our water, we're going to do this in Celsius. Just like we've been doing all year. Temperature in Celsius. So this is one of the pieces of information that I'm going to look for. I'm going to look to see that you've recorded the mass of your water. All right, so we are going to report our food in food calories. So if I look at the back of a food item, they all have nutrition facts. This food calorie is 1,000 science calories. So this is actually a kilocalorie, okay? So the science calorie is the amount of energy it takes to increase the temperature of 1 gram of water by 1 degree Celsius. Okay, that's what a science calorie is. That's a definition, okay? But this gives us pretty big numbers. So in order to report things that are usual, we have to take our number and divide it by 1,000 and report it as kilocalories. So 1,000 food calories is 1 kilocalorie. Okay. So when you find your energy, the Q, in the previous slide, you're going to take that number and divide it by 1,000 to get kilocalories, and then that will match what's on the back of the food item. So I want you to report your number in actual food calories. Does that make sense? Okay. And this is one of the post-op questions explaining this. All right, so here's another data table that you're going to need. So we are going to, every time you start a new experiment, you're going to measure the temperature of the water. That's going to be your initial temperature. Then you're going to put your water container on top of your furnace. You're going to start your food on fire. Then you're going to let it burn out. Once it's done burning, once it's burnt out, then you're going to retake the temperature of your water. That's going to be the final temperature. Okay? And then you're going to get ready for the next measurement, and then you're going to re-measure the initial temperature. Okay, so it'll fluctuate a little bit. Okay, so I need to see the initial and final temperature for 4 different foods that you measure. Does that make sense? So I might pick 2 Cheetos and maybe 2 almonds or something like that. We found yesterday Cheetos burned really good. The puffed Cheetos burned really well. The Cheez-Its did not burn very well. So keep that in mind when you're cooking your food. If you have another way of recording your data, that's fine. This is just an example table.
What? I don't understand. Yeah.
So when you pick your food, you might want to write Cheeto 1, Cheeto 2, or Corn Puff 1, Corn Puff 2, so that you know what you're measuring. The other thing that I think would be good to do is to write the grams of your food. So we are just going to be measuring the heat released from a piece of food. And then if you take that number and divide it by the mass, then you're going to get a better idea of the calorie content of the food. So if you do calories per gram, then you're going to be able to compare different foods and see which one has more calories per gram. Or if you do like a giant Cheeto versus a tiny Cheeto, then that will help normalize the number that you're getting. It'll make more sense. So that's something that I would do. I would write down the mass of each of the foods and then take my calories at the end and divide by the mass of the food. That's not in the instructions, and I'm not going to take points if you don't do that. But next year I'm going to fix that because I think that gives us a more clear picture of what's going on. Okay. All right, and then we have some post-lab questions. I changed question 4. So on the paper it says, what are you breaking or forming bonds? But now I want you to tell me what type of chemical reaction you're measuring. I think that makes more sense. Okay, are there any questions? So we're going to work in groups of about 2 to 4. I am going to give each of the groups a lighter. If you don't give me your lighter back at the end, then your group will lose all of your points for this lab. Also, if you're doing, I'm not worried about your class, but if you're doing anything like goofing off, either with like, we are working with like this really sharp pin, if you're goofing off with that or the lighter, then I'm going to ask you to stop the lab and you'll lose all the points for lab. Okay. Okay. Questions about the lab before we go to the lab? Okay. All right, so this lab, we are going outside, but I am going to ask you to still wear safety glasses, just we don't want any flaming food in our eyes. This is also a lab where we will have a lighter, so if you have long hair, I'd probably pull back your hair just so that it's not, there's no chance of it catching on fire, okay? All right, so groups of about 2 to 4, go ahead and get your equipment. Let me hand you out a sheet. And then we're going to head out. If you see there's like a cement wall thing here, that's a good place to work. It's about. So let's talk about a few of these post-lab questions. The other class was missing these, so let's just make sure we know what's going on. So do you think this is a reasonable answer? Once you get your number, you're going to do mass of water times change in temperature divided by 1,000. Okay.
Oh.
And then why or why not? So does that number make sense? Explain why, okay? So this lab, explaining why is really important, okay? And then this next question, how could you improve the reliability of your results? So maybe you want to explain that maybe not having wind, right? That would make it easier to get more reliable results. That will only give you 1 point. You need to explain how not having wind will affect your results. Does that make sense? So not having wind does what for your experiment? Yeah?
I would stop the temperature from dropping if it can.
Okay, so your sample cooled off, so that would help us keep a consistent temperature with our water. It would also help your food to burn more consistently, and that will give you a higher calorie number, okay? So explaining, you can't just tell me that will give you just 1 point. Make sure you explain how does your improvement give you better data, okay? And then this one, what type of chemical did you measure? What did we measure? What kind of reaction is this? From, sorry?
And what have a chemical reaction?
What type of reaction is it?
Combustion.
Good, it's a combustion reaction, good. And then this one, explain the difference between a calorie and a kilocalorie. So you should be able to do that from our notes. 1 calorie is, or 1,000 calories is a kilocalorie. One of them is a 3 calorie, one of them is not. Okay, questions on the post lab? Does that make sense? We got about 15 minutes.